Hey everybody, your Friendly Math Tutor here. Welcome to episode 3 of our SAT Prep mini course, where each episode we're going to dissect a strategy that you can apply to your upcoming SAT. Let's get started on our closer problem from episode 2. So to recap, this was College Board Practice Test 4, section 4, number 25. They gave us two functions, f of x and g of x. And what we had to do is find out which of the following polynomials is divisible by 2x plus 3. And then we have four answer choices. A was f of x plus g of x. B was f of x plus 3g of x. C was 2f of x plus 3g of x. And D is 3f of x plus 2g of x. Now, the school way we are not going to actually do because it takes so much time. What we would need to do is, first of all, this is one where you have no choice but to check all of your answers because we have to figure out, it says which of the polynomials is divisible. So which of them, we would have to kind of check all of our answers. We don't have another choice. And then in order to do that, so for instance, A, we'd have to actually add f of x and g of x together. So we would have to combine like terms and simplify. And then we'd have to divide by 2x plus 3 using long division. And then we would see if we got a remainder of 0, then it would be divisible. That's a bit of a process just to check A. We'd have to repeat that at least, or at most, 2 more times. And so hopefully you can see that the school way in this case is just not going to happen. So we're really going to use our strategy that we learned last class, which is pick your own values. So let's start by writing down the value that we're going to pick. I'm going to choose x equal to 1. 1 is a nice, easy number to plug in, all right? And what I'm going to do is I'm going to find f of 1 by plugging that into the f function. And by plugging in 1, that simply just makes this 2 plus 6 plus 4, which is 12. And then I want to find g of 1, which that's simply 1 plus 3 plus 2, which is 6. Lastly, I'm going to plug 1 into this expression that they're asking us whether it's divisible by. So 2 times 1 is 2, 2 plus 3 is 5. So we need it to be divisible by 5. So let's just recap. I chose the number x equal to 1 just because I feel like that is an easy number to plug in. If you chose a different number, you would have a different value for f and g and a different number that it was divisible by. But when we go through and we check all of our answers, we would all arrive at the same answer. So the next thing I want to do is basically just check my answers. So A is saying f of x plus g of x. So 12 plus 6 is 18. Is 18 divisible by 5? Definitely not. So that answer is wrong. Now we look at B. Well, B says f of x plus 3g of x. So that is 12 plus 3 times 6, which is 30. And is 30 divisible by 5? Well, yeah, 5 times 6 is 30. That does not tell us that this is automatically the answer. We have to understand when applying this strategy, we are eliminating answers. It is possible that B worked for 1, the number that we chose, but may not work for another number. So what we're hoping is that this will eliminate the other 2 answers, and then this will in fact be our answer. So let's see. So we go C. C says to do 2 f of x plus 3 g of x. So that's 2 times 12 plus 3 times 6, which is 24 plus 18 is 42, and 42 is certainly not divisible by 5. So this is a calculator section, but hopefully we remember the divisibility rules for 5. Anything that ends in a 0 or a 5. So 42 does not fit that. And lastly, we look at D, and D tells us 3f of x plus 2g of x. So that's 3 times 12 plus 2 times 6, which is 36 plus 12, which is 48, and that does not work, all right? So our answer is B. If you got B and it worked and you just picked it and moved on, you would be lucky that this was the answer. So I want us to understand the logic behind this. When you choose your own values and plug in and then plug into the answers, we need to make sure that we get 3 wrong answers and 1 right answer. All right. Feel free to try this, but if you tried x equal to 0, I think last episode I mentioned, are there any values that may not be good? 0 is not the best here. If you plug in 0, it ends up working for multiple answers, and then you have to choose another value, which probably would be 1, right? But you don't always know that going in, so don't think that if you chose 0 that you did anything wrong. But definitely in this case, 0 and 1 are the easiest numbers. I stayed away from 0 personally because when you plug in 0 to the first function, you just get 0. And so when most of these answers are 0, it just makes me think that something strange is going to happen. And it may not necessarily lead us to just one correct answer. All right, so let's move on. All right, on to today's topic, which is slope-intercept form word problems. This is not necessarily like the last 2 episodes, a strategy that could apply to a whole wealth of different types of problems. It's mostly going to be for a few specific types of problems, but I see them all the time on all types of SAT practice tests. So it's really important to recognize these problems. And one of the main strengths of this type of problem that we're going to look at today is it's going to save a bunch of time. All right. So this is great for word problems in which the equation is given in slope-intercept form. In the reality, it's only useful for those. It's important that we're going to learn some key words that are associated with both slope and y-intercept. And it's also going to be important for you to identify when something is in fact in slope-intercept form. It's not just going to be obvious where it says y equals 7x plus 8. They're going to disguise it. They're going to switch the order. They're going to put different letters or variables other than x and y. For these problems, it's going to be a little different because there is really no school way. You're not often, it doesn't have like a procedural way. There's going to be very little work required. So we're going to really just kind of just talk about each problem and list out a couple words. And we're going to go through these actually pretty quickly today. All right. And one of the biggest takeaways, and this is something that's going to apply to the next episode also, and really just in general, you don't have to read the entire problem, especially when you're on like section 3 has a little bit, but section 4 of the SAT tends to have a lot more reading, and it can be quite daunting if you feel like, how do I have time to read all of this? Well, the reality is we have to get good at not paying attention to certain information, and for these specific problems, you are not going to read all of it, and we'll talk about it more specifically. So on that note, just because I want to make sure everybody knows what the problem is in case you're having any trouble seeing this, or I had to write a little smaller than normal because these are wordy problems, I am going to actually read this whole thing. But then I'm going to tell you to not read it, all right? So this one is, our opener problem is College Board Practice Test 1, Section 3, number 4. And it says, Kathy is a repair technician for a phone company. Each week she receives a batch of phones she needs to repair. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value 108 in this equation? All right. So you come up to this problem on the SAT, and my suggestion is don't read it. When you see the equation, just look at the equation. This is a rearranged form of y equals mx plus b. All right. And in this one, I would notice this equation. I would ignore all of this, because once you start reading about Kathy and her job in the phone company, your brain starts firing and tries to figure out what's going on. And the reality is we don't care about any of that. All we care about is this equation and the value 108. You don't have to read anything else. So we're looking at 108, which is really in this position. It is the constant. It's the y-intercept. So our whole point of this problem is just to interpret the y-intercept. All right? Now, I'm just going to list out some words that are really important for a y-intercept in a real-world problem. And the words you're going to look for is start, begin, initial, or sometimes it can be a flat fee. But again, a flat fee is something that you pay at the beginning. So any kind of word, this is not an exhaustive list. There are other words. You'll come up across them. We'll come up later in this episode across another maybe type of word. But as long as the word means one of these, something at the beginning, some starting value, that's what a y-intercept is. So when you see a problem like this, and again, I'm not saying that when you see a long paragraph that you just skip it and you don't read it. But when you see an equation embedded in there, just go right for the equation and then look at the end and say, okay, they're asking me what 108. 108 is the y-intercept. All I have to do is know what a y-intercept is. I don't have to understand in the context of this problem, actually, because, again, we're trying to save some time and we're just trying to use some logic here. So if we look through our answers, Kathy will complete the repairs within 108 days. I don't see anything there that talks about beginning or initial or starting. Kathy starts each week with 108 phones to fix. Well, there we go. She starts each week with the 108, so that seems to make sense. If we look at the other ones, Kathy repairs phones at a rate. Well, a rate, we're going to see in the next problem, is a sign of the slope, not the y-intercept. And Kathy repairs phones at a rate, again, another rate. So two rates, neither rate fits what we're trying to do as far as the y-intercept. All right? So that's it for this problem. All right, let's move on to the second problem. This one is College Board Practice Test 1, Section 3, number 6. It starts out with an equation, h equals 3a plus 28.6. It says a pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? A, 3, B, 5.7, C, 9.5, or D, 14.3. So this problem, they ask it in a little bit of a different way. In our last problem, they just gave us they told us what number we were looking for, and that number was in the position of the y-intercept. Now they're just asking us what represents the estimated increase. So just a quick review. Y equals mx plus b, we know that m is the slope. All right. So some key words that you want to look out for slope is increase, decrease, rate of change. Sometimes you'll just see rate, sometimes you'll just see change. And another thing is the word per. If you see the word per, you know it's a rate. If it's a rate, you should associate that with slope. So what we're doing in this problem is, what I would suggest is once you see the equation, I would skip ahead to just the question, all right, and see, is there a way that I can answer this without reading the whole problem? a lot of times in these problems, it's not going to be possible, so you're going to have to go back and figure it all out. I'm not telling you to just not read anything. Reading is extremely important. But if I have an equation and they're asking me about the estimated increase, well, I know that increase is something that's a sign of slope. I don't see them telling me anything about a starting, beginning, initial value that would tell me to look at the y-intercept. All it's telling me is what's the estimated increase, which I can associate with slope. And I look at this equation, which again, they switched the letters, but they didn't even switch the order. So the slope is always the coefficient of the variable, and the coefficient of a is 3. That's the slope, so that must be the answer. So we have an answer of a. Now, for this problem, I wanted to just show you, this is not necessarily like the school way or anything. This is just a backup way to do this problem. And it's really more of a review of last week. So it kind of goes with the theme of the course, is that there's not always just one way to do these problems. And it also, and some of the strategies that we're learning about apply to multiple problems. So I wanted to just take a minute to talk about this problem. Again, the quickest way is read the equation, estimated increase, increase is slope, slope is 3, so the answer is A. But let's say you read this and you didn't remember that, and you know. So what you would want to do in that case is you would want to pick some values. So this is what we did last week. So what I would do is maybe start out with A equal to 2, because it says it's only based between the ages of 2 and 5. So in this case, you would have to go back and read a little bit. So if A equals 2, I got 3 times 2 plus 28.6, which is 3 times 2 is 6. 6 plus 28.6 is 34.6. And then what I would do is ask for the estimated increase in the boy's height each year. So each year would mean I would change the age from 2 to 3. Now I would do 3 times 3 plus 28.6, and that is 9. 9 plus 28.6 is 37.6, and then the increase would be from 34.6 to 37.6 would in fact give us 3. All right. So increase per a single unit is essentially what slope is, which is why we could have got this answer right away. But again, if we don't remember some of these things, we always have these other ways to go about that. So I would say today's strategy of basically really just analyzing these slope-intercept form word problems, this particular one we could use last week's method of picking your own values, could allow us to figure out the problem. All right, let's move on to the third problem. So this one is College Board Practice Test 6, Section 4, number 13. It says the function h defined by h of t equals at plus b, where a and b are constants, models the height in centimeters of the sunflower after t days of growth during a time period in which the growth is approximately linear. What does a represent? Right. So again, a lot of words. But all we really need to be focused on is, I see a paragraph, but I see something in terms of that looks like y equals mx plus b. They've got it as at plus b. And then they are asking us, I'll go right to the question, what does a represent? Well, if we look at it like this, we've got y equals mx plus b, and they're giving us the function h of t equals at plus b. Well, they're asking what a represents. Well, a is just in the same position as m. So therefore, it's the slope, all right? So think about some words that we talked about for slope: increase, decrease, rate, per, right, change, something like that. So let's see if we can read the answer choices and eliminate some. So A, the predicted number of centimeters the sunflower grows each day during the period. Possibly. B, the predicted height in centimeters of the sunflower at the beginning of the period. Well, the word beginning tells me y-intercept, and that's not what they're asking for here. So I would get rid of B. C, the predicted height in centimeters of the sunflower at the end of the period. Well, at the end, we haven't even talked about what anything would be at the end. So these numbers, M and B, have nothing to do with the end, all right? So that one just doesn't make any sense. D, the predicted total increase in the height of the sunflower in centimeters during the period. So, oh, I see the word increase, and your friendly math tutor told me anytime I see the word increase, that must be the answer. But that's not correct. So I don't want you to take away from this that, oh, I looked for one single word. Like, that is not the idea here. It's to think about it and use these strategies to save some time. But we have to understand that this one is saying total increase. What slope is the amount that the dependent variable, or the y, is going to change when the independent variable, or the x, changes by 1 unit. That is what slope is. So in this one, they kind of trick you by throwing in the word increase, but total increase, it's not a total increase. It's how much it's going up every time we go over by 1 unit on the x-axis. So A actually is the word grows is just another word for increase, all right? So there's a bunch of words that mean increase. I can't list them all up here. We have to know that the word grows is another word for increase. We want to stay away from total increase. And the key is it's how much it grows each day. So growing each day, a day is 1 increment or 1 unit of time. So that is exactly what slope is. So we have to have a very good understanding of slope. These keywords are just things to kind of like point you in the right direction, but they are by no means this, again, this exhaustive list that you can say, oh, I'm going to memorize these 4 things, I'm going to see this problem. It doesn't really work that way. We're trying to save time, again, on a timed test, but we are not trying to throw logic and thinking out the window, all right? We've got to combine everything, all right? So this answer ends up being A, the predicted number of centimeters the sunflower grows each day during the period. So again, grows is another just specific word for increase that wouldn't apply to everything, but it applies here to flowers. And each day, as opposed to the total increase. All right, I hope that makes sense. All right, on to the 4th problem. This one is College Board Practice Test 5, Section 3, Number 8. In air, the speed of sound s in meters per second is a linear function of the air temperature T in degrees Celsius, and is given by S of T equals 0.6 T plus 331.4. Which of the following statements is the best interpretation of the number 331.4 in this context? So the first thing we would notice is you would see this paragraph and you'd be like, all right, I'm not reading this whole paragraph. Let me just like look for some things. And you'll see this function. So S of T equals 0.6 T plus 331.4. All right. Then we skip down to the question. And in the question, it just wants to know what 331.4 is. So now I know that I am looking for the y-intercept. So some words we mentioned earlier, begin, start, initial, are all keys or keywords that we look for. But if I look through these real quick, the speed of sound in meters per second at 0 degrees Celsius, the speed of sound in meters per second at 0.6 degrees Celsius, the increase in the speed of sound in meters per second that corresponds to an increase of 1 degree Celsius, or the increase in the speed of sound in meters per second that corresponds to an increase of 0.6 degrees Celsius. Well, I don't see those words anywhere in there, so they're not always going to help us. Again, we can't just memorize a list of words and then just think we're going to apply them. We have to understand what they mean. So let's talk about the reason that this is the initial value. It is the y-intercept. So you should remember from algebra, the y-intercept is the value when x is equal to 0. So if you think about a graph, right, and that's a line, the y-intercept, the coordinates is always going to be when x is 0, all right? So when your input 0, your output is always going to be this value. So another way of looking at just initial and starting is just when the input is 0. So that tells us that A, the speed of sound in meters per second at 0 degrees Celsius. We know that degrees Celsius is how we're measuring temperature here, and temperature is the independent variable, or it's the x, it's our input. So we have to be able, they're going to use different letters. That's where we may sometimes have to go back to the problem and just read like little words here and there just so we know exactly which variable is which. But it's also, you know, the S is on this side and T is on this side, so clearly T is the independent variable. Also, when you look C and D, they do use the word increase. So increase is not going to be associated with y-intercept. B is the speed at 0.6 degrees Celsius. Well, that's not the y-intercept. So again, initial, starting, beginning, but plugging in when the independent variable is 0 is also another way to look at the starting value. Okay. Moving on. All right, now to the closer problem. So we'll end with College Board Practice Test 7, Section 4, number 17. This one starts with the equation y equals 19.99 plus 1.50x. The equation above models the total cost y in dollars that a company charges a customer to rent a truck for 1 day and drive the truck X miles. The total cost consists of a flat fee plus a charge per mile driven. When the equation is graphed in the XY plane, what does the y-intercept of the graph represent in terms of the model? A flat fee of $19.99. B, a charge per mile of $1.50. C, a charge per mile of $19.99. Or D, the total daily charges of $21.49. All right, so just some things to think about. What is the equation that we're looking at here? And what is it that they are looking for in the problem? Is this equation in the same order that you normally see it? And think about the specific aspect that they're looking for. What are some key words that we talked about today that you could use to figure that out? All right, now to today's takeaways for slope-intercept form word problems. So the most important thing is for you to just recognize, you come across a problem that's got this long paragraph, and you just want to recognize either before the problem starts or somewhere in the problem, if you just see an equation that looks like it's in slope-intercept form, you can just not read the whole thing. You just go right to the end and see exactly what they're asking about. And then you want to remember some key words. So whenever you see initial, start, begin, sometimes when the output, when the input is 0, in some real specific word problems, you look for like a flat fee, could be some initial, some flat fee that you're charged before you're charged every month, say. That will be something that you're charged a flat fee in the beginning, all right? So that's for the y-intercept. For slope, you're looking for words like increase, decrease, rate of change, or the word per. For instance, like miles per hour is a rate, and a rate is a slope. Be careful with the words increase, decrease. They should be increasing per a single unit, as opposed to like a total increase or a total decrease, which could be there as a distractor for you, kind of enticing you to pick those answers. So we really, really need to think about why these words do mean, so for instance, slope, why it's increase, decrease per unit of time or per single unit, or why the y-intercept is initial or starting or beginning. Again, we talked about when we graph it, it's when you plug in 0, a 0 would be the beginning of most word problems. So that is the reason. So that is it for episode 3. Please comment or like the video, subscribe to our channel. If you have any questions or anything, if you have any specific topics where in the future you'd like me to make videos on, please feel free, give me ideas. I'd love it. Make sure you follow us on Instagram, Facebook, Twitter. Until next time, your Friendly Math Tutor is out. Scratch that, this problem. Well, that fell. All right, scratch that. We're going to do this again. Nope. Right. Let's do this again. All right. All right. Don't use that.